Everything is nonlinear. It's just that sometimes an estimate with a basic linear static study isn't good enough. Nonlinear simulation in SolidWorks picks up where a regular simulation stops in terms of accuracy. It's where an estimate isn't quite good enough. Now, there's only a few cases where linear simulation is okay. First, the material is linear and elastic, which means there's no permanent changes. Looking at the geometry, deformations or changes in shape are small, indistinguishable with the naked eye. And then boundary conditions, where loads and fixtures are applied without change in magnitude and direction. Anything beyond this, which is a lot of cases, you need to turn to nonlinear simulation. Here's how it works. Take this hose clamp, for example. It starts off straight and then gets wrapped around a circular hose or pipe. First, the linear static analysis. It's got a regular stainless steel material. The rotation is applied and it's held on one side. But see how far off this is from the real world? It's because it's beyond the capabilities of a linear static analysis. So now, a nonlinear study. The setup is exactly the same, but some additional functionalities unlocked. The material applied is a nonlinear material. There's several options now available to accurately account for this complexity. In this example, we're using the tangent modulus to easily create a bilinear stress-strain curve. Next is the loading, which you can vary over time, which gives you more control. So now the results. And we can see here, it's accurately capturing what happens in the real world, driven by the additional capabilities unlocked with a nonlinear simulation to account for nonlinear materials, geometry changes, and boundary conditions. And that's the power of nonlinear simulation in SolidWorks.